Good morning, students. In the CET class, the next problem in the electric potential and capacitance. Question number 149. You are given this circuit diagram, and this problem is very important ones. Very important. In this circuit diagram, you are given a cell. This small r is a resistance in series with the cell, okay, and then resistance is connected across this combination of the E and small r, and between A and B, capacitor along with the series resistance R1 is connected. Symbols can change, and sometimes they will give you internal resistance of the cell also separately, okay. Wherever the internal resistance of the cell given, that should be taken in series with this. If they give this as R0, for example, total resistance in this diagram, in this part, branch becomes equal to R0 plus R. Internal resistance comes in series only, okay. So next, here not given means they are given as not EMF, but they are given it as a voltage only. Already given that the potential difference across this is given for you. So internal resistance not given means take it as an ideal cell also. Next is you have to find the voltage across A and B. So this arrangement is similar to this part I am taking, only this part. It is similar to the voltage division. Two resistors in series, this small r and capital R, and capital R2 it is. Across the capital R2, the combination is connected here, that is capacitor. This R1, whatever is coming in series with the capacitor, must not be considered. Why not considered is, initially when you switch on the power supply, charges will go and sit on the capacitor. Once the capacitor is fully charged, charges do not move anymore. Plus minus fully charged, charges on this capacitor is Q reached maximum charge. After that, what happens is no more place for the charges to sit on that, charges do not go onto the capacitor. When charges are not passing through this, there is no current in these branches. So resistance is counted only when the charges are passing through it. Opposing to the motion of the charges itself is a resistance. If charges are not going, there is no question of resistance. That means you have to take this R1 equal to 0. So we have to take this capacitance resistance relation, whatever you are taking this series with the capacitor, no, R2 is 0, you have to take, sorry, R1, symbols can be reversed, R1 is 0. Don't consider the resistance coming in series with the capacitor after long time of the power supply on. That point is important here. Then what about the voltage across the capacitor? Then this is a cell side, reverse connected, no, this is minus, this is a plus, okay, according to the comparisons. So plus side, this is going to be A, this is B, whatever, does not matter. Voltage across this R2, whatever you are taking, is VAB. That is the voltage across the capacitor. So what is the voltage here? Is the voltage across this capacitor. So VAB, C equal to Q by V formula you take it, but C equal to Q by VAB. So we have to find is VAB. Already we have discussed about the voltage division. Capacitor, current do not pass through the capacitors, because between the plates what is present is dielectric is present. So whatever current is coming will be passing like this only. This is the only current passing direction. Here current will be 0. In this branch, current is 0. So this only current is present. I will take it as I prime. Here there is no current passing after fully charging of the capacitor. The charge on the capacitor is Q, and the series resistance R1 you take it is equals to 0 after long time. That resistance become equal to 0. So only charges. So the current is not passing through this. Voltage across this equal to voltage across this you have to find out. So VAB you have to find out. What is the voltage across this AB? Is VAB. VAB. What is VAB formula? This is V1, V2 we can take. What is V2 equal to this R1, R2. Okay. What is the V2 across the voltage across the resistance division is nothing but equal to V2 equal to V into V1. V1 is equals to total voltage V into R1 by R1 plus R2. If you remember that relationship. This is the total voltage V. This is R1, R2. Voltage across this V1, V2. Current is same. So what is V1 formula? V into R1 by R1 plus R2. For capacitors reverse. For the capacitor series if you have taken means V1 is equals to V into C2 by C1 plus P2. But resistors not like that. V1 is equals to V into R1 by R1 plus R2. V2 if you want, no, V into R1 you have to take, reverse you have to take it. So V2 is equals to V into R2 by R1 plus R2. So this is R1, this is also R2 if you take. Okay, this R1 of course given is different thing, just comparison I am taking. So VAB equal to V into that resistance only, R2 by R2 plus R. Point answer. After long time, current through capacitor C and series resistance to capacitor to C, that is R1. After long time, means after long time of the switching of the power supply, current through capacitor C and series resistance to C, that is R1. Series resistance R1 to C is I prime equal to 0. There is no current. When the current is not there, that device, whether it is present or not, makes no difference. But voltage will be there for the capacitor, not for the resistors. Hence, therefore, R1 is made 0. R1 becomes equal to 0, means should not be considered. Previously, we are taking current not passing. R1 can be infinity conditions we are taken. Okay, like that also you can take. But here, if your charges are there, you can take infinity also. If you take it, does not matter because current it is not at all present. So, but whatever it is, we just take it as a short circuit current because we are calculating the voltages here. Open circuit don't take, infinity means it becomes open circuit. So, it will not be connection with the B. So, I am taking it as a short circuit here for the R1 only. Or we should not consider, R1 is not considered, we should not call it as short circuit, you should not be considered, make it as a 0. Or removed we can take, R1 is made 0 and removed. Removed means again it will become an open circuit, no, better make it as a short only. Next, so voltage across capacitor is equal to VAB. And what is VAB? VAB is equal to total voltage V into that resistance across the capacitor, that is R2 by R2 plus R is the formula. This V is the total voltage that where V is equals to, we are taking is E, that is total battery voltage. This is the formula, or we, in terms of the E symbol given, so we take it as E into R2 by R2 plus R is VAB. Okay, what is the capacitance formula? And C equal to Q by V, capacitance. C is equals to Q by VAB you have to take. But we are asked to find out the charge value. What is Q becomes S. Therefore, Q is equals to C into VAB, which is equals to C into VAB. VAB is E into R2 by R2 plus a small r. C into E into R2 by R2 plus R. You should not take so many steps to work out this problem. You should not take any steps only. This problem will be repeated multiple times. It was repeated multiple times. Small variations of symbols. R1 can be here given, R2 here, small r instead of here, R may be given here. One more R may given, whatever it is. This one more resistance given here, anything. This take the total of that as a single resistance. As a summation comes in the denominator only. But numerator comes is the resistance coming parallel to capacitance, that resistance. So, VAB equal to this total voltage into that resistance by all resistance what are coming in series with this. Okay, symbols can change also, you must be able to work out this, it is very important one. So, option A is CER2 by R2 plus a smaller, that is a third option. Next 150th question. Question number 150. We are given one block and spring connected to the wall. Okay, smooth surface, mass of the block is M, it is smooth surface, friction is not there, let us neglect, and charge on this block is Q plus Q. The spring constant is K. Block of mass m and charge Q is tied to a spring of constant K. Okay. Electric field is applied in this direction everywhere. Uniform electric field is applied. Okay. As switched on as in diagram. The maximum displacement of the spring is how much? So when it is applied, no positive charge experiences force in the direction of the electric field. So F equal to QE will be acting in this direction. The block will be displaced some distance. Some distance it is moving. The distance moved is say x. So spring also expands by the same distance x. The spring expands in this direction. The expansion of the spring you have to find out. For the spring formulas, what we have is spring energy is equals to half k x square. This is also equal to work. Energy is also equal to F is also equal to minus kx. This is the formula. If you take minus if you take means the force is external force. If you take the plus, no, that is going to be, if you are taking the internal force of the spring, minus you have to take, that is a restoring force. If you are taking the external force, we take it as a plus, whatever is. F is proportional to x, F equal to kx for the springs. And energy stored in the spring is potential energy, expand or contraction by the distance x, same thing, expansion or compression of the spring, energy is half kx square, that is also equal to work done. And F is nothing but equal to kx, but work is equals to force and distance. If you take the relationship, same work also can be taken as average force into x, which is F plus 0 by 2 into x is the formula. That means F by 2 into x. This is the formula you have to take for the springs. That formula we are going to use here for this case. So whenever the force applied on this, neglecting the friction, only one force acting is electric force F equal to QE, that pulls this block in this direction, so a spring expands. Okay, so F equal to MA, F equal to QE, and F is also equal to Kx. You are asked to find out is what is the displacement x. X is displacement of block, is also equal to displacement of the block, it is also equal to expansion of the spring, expansion of the spring. So work done by electric fields, work equal to force into distance. And what is the force formula? First we will take F equal to QE, work done, W is equals to F into x, force and displacement same direction, Fx cos theta, cos 0 you will get maximum work done. Fx, force and displacement, this is by electric fields, that means you will get it as QEx, and work done is nothing but equal to energy stored, energy, that is a potential energy of spring, potential energy of the spring. Half kx square, equate these two and get the expression for k. You are asked to find out what is the value of k. In the diagram, find k equal to how much. I repeat, I didn't write the question for this. In this problem, they have given the diagram, we are referring to the diagram. What they told is, when electric field is switched on, the block moves by the distance equal to x, expansion of the spring they given as x here. Both are tied means the same displacement. What is the value of the direct force constant of the spring? So our spring constant it is called as. So F equal to QE, F equal to QE, work done by the electric field is Fx, QEx, energy stored is half kx square. Equate these two works and energies. So what you get is half kx square equal to QEx, 1x cancels, k we want equal to 2QE by x is the formula. Sorry, you are asked to find out k, no? You are asked to find out displacement, no? X you are asked to find out, not k, sorry. X equal to by k. Next question is 151. 151. We have 3 plus 2 capacitors on total. Connect to the battery. This side 3 capacitors and connected to earth. Earth potential is always 0, and this side we have 2 capacitors. Here point A, this edge point is B, and this potential, this O I will take or C we can take Rho, VO equal to 0, that is earthing, and voltage of the battery is equals to 10 volts plus minus. So, this is a positive terminal, voltage here will be VA plus VA, this is a negative terminal. So, this voltage terminal part B becomes equal to minus VB. If you take any cell, any battery cell, the voltage is given as equal to say 6 volts if they given. So, potential difference it is supposed to be 6 volts. That means with respect to 0 we need to consider. With respect to 0, this is a plus, this is a minus. So, V1 I will take, V2 I will take, V1 and V2. V is nothing but equal to V1 minus V2 is V, that is equals to 6 volts. Difference should be 6 volts. So, with respect to neutral, how much is this voltage? This end terminal is, this is 0, I will take neutral with respect to this. So, this is going to be 3 volts and this is going to be minus 3 volts. V2 is minus 3 volts. So, if you take the potential difference 0 neutral, this terminal is 3 volts higher than 0, this 3 volts lower than 0. Potential difference becomes what? 3 minus of minus 3 becomes equal to plus 3, becomes is 6 volts. So, this is negative terminal is minus no voltage below the earth, below with respect to neutral point you have to consider. So, here we are given all capacitors equal, they are in series. So, this whole thing becomes equal to C by 3 identicals, this whole thing becomes equal to C by 2. Okay, voltage across this I will take it as VA, this point equal to V1, this voltage is V2, and this is higher potential, that is low negative, and this one you get means other one you can easily get it. So, voltage V1 plus V2 is supposed to be equal to V. Okay, so what is V1 we can take is V1 is equals to V into C2 by C1 plus C2. C1 is C by 3, C2 is C by 2, combination of this. If you take imagination like this, C1 C2, V1 V2, V is total voltage. What is this result becomes? E is equals to, this V1 is related to the positive voltage with respect to 0, is total voltage is 10 into C2 is C by 2 by total capacitance C by 3 plus C by 2. How much you getting this? CC cancels, 6. This is 5 by 5C by, this is going to be 5C by 2, no, only 5C the numerator, this is going to be 5C again by 6 volts, 6 go to the numerator, it will get is 6 volts, but it is plus 6 volts. So, VAB equal to plus 6 volts. Once you get plus 6 volts, other voltage already you know it, that is supposed to be negative you have to take with respect to origin, that is not VAB, sorry, VAO, or just VA we have to take with respect to O only. So, VA is plus 6 volts, potential VB is minus 4 volts, minus 4 volts. You can check up the remaining is totally 10 volts. Therefore, VAB what happens is VAB equal to VA minus VB, which is equals to 6 minus of minus 4, it is supposed to be 10 volts. Careful with the problem of this kind. I have taken them as a imagination as a series combination, then calculated by the voltage division methods with respect to that point neutral you are taking. Next 152. So option is 6 and minus 4 at A and B they ask. Single point they ask the voltage here with respect to O. Next is 152. Charge on the capacitor A is Q, and what is the charge on B? After a long time the switch S is closed. After a long time, for capacitor on the long time, no, after long time means current will not be there in that group. When you switch on, instantly charges to go and sit on the plates, current will be there, fraction of seconds or minutes sometimes depending on the capacitors. Large capacitor if you have taken means, then it will take more time to set the charges. That time ammeter in the series to show the readings, but afterwards it does not show any readings. After long time if this means current through the capacitor is, capacitor circuit what you have taken, that will be 0. Resistance only has the current, not the capacitors. Whatever. Here the circuit diagram is different ones. 152. Charge on the capacitor A is Q, and here switch is closed. Open, first it is opened. And charge on B is, what is the charge on B? After a long time the switch S is closed. Is A and B. Only one capacitor is charged, but charge to flow from one device to other device compulsorily you require closed path. But if you have the two spheres if you have taken with the charges Q1 and Q2, they have the different potentials. Charges can travel from one capacitor to other, one sphere to other sphere until both get the common potential. But if we have the capacitors in parallel, now also closed circuit is there for the charges to flow from one capacitor to other capacitor. But here it is not a closed circuit, just open circuit, it is not closed. Then charges cannot flow. If that is closed circuit is given, already we have calculated what is the combination. That means if in case if it is closed like this, then you can rotate this capacitor and it becomes parallel to this. So the condition common potential what you have taken, that we can take and we can find out the charges on each also. But here it is an open circuit. For open circuit charges do not flow. So initial charge is Q here, charge afterwards also charge is same, Q1 prime, and this Q2 prime will be 0 always. Charges do not flow. After switch, so 1 minute, initially Q1 is Q, Q2 is 0, okay, C1, C2, whatever is the capacitance. After closing, this is before switch closed, this is before, or we can take initially means switch open, initially switch open. Next is switch closed. Switch closed. When you close the switch, open circuit charges do not flow. For open circuit, charges do not flow. Therefore, Q1 prime, Q1 is equals to Q only, Q1 and Q2. And Q2 is equals to 0. I will write as new charges Q1 prime, new charge here is Q2 prime. Q1 prime is equals to Q1, that is Q only, and Q2 prime is 0 only, do not change. No flow of the charges. Next question. This next question 153 is also very important one. 153. You are given 3 capacitors. 3 capacitors. Capacitances are C1, C2, C3. These junctions A, B, C. C1, C2 and C3 are the capacitors. The junction point is O. If potentials A and B, C are given as V1, V2, V3, what is the potential at O? If potentials at A, B, C are V1, V2, V3 respectively, find potential at junction O. VO we have to find out. O. That is VO equal to how much? So I will take this potential as at this point VO. Okay. So let us imagine that we are giving the charge from A. Okay. Then it is divided into 2 parts. So let us take this charge as Q supplied from here, and here it is Q1 and Q2. Okay. So Q is supposed to be equal to divided into 2 parts, Q1 and Q2. Let Q is charge on C1, Q1, Q2, charges on C2, C3 respectively. So Q is equals to Q1 plus Q2. What is C equal to? Q by V formula you have to use. So C1 is equals to Q by VA minus VO. VO you have to find out. What is Q? Q equal to C equal to Q by V. Q equal to CV. So C1 into potential difference, that is VA minus VO is equals to Q1. Q1 is nothing but equal to, you are taking this as given potential from here, means you take it as a positive. So this side will be higher potential than this potential. One order only you have to take from higher to low potentials. Charge is going. Imagination positive charge initially given is equals to Q1. Q1 is nothing but equal to C1, C2. Sorry, 1 minute. We will take this as Q1, Q2, Q3. So that C1, C2, C3 easily रहता है. Q2, Q3. So Q1 C1 into VO minus VO. Q2 is C2 into VO minus VB plus C3 into VO minus VC. Expand it further. C1 VA minus C1 VO equal to C2 VO minus C2 VB plus C3 VO minus C3 VC. So VO terms you take out one side, this one take it to the right side, becomes equal to plus C1 VA plus C2, this one take it to no C2 VB plus C3 VC. I am taking these negative terms to the left side, becomes positive. This one take it to the right side, becomes plus. E is equals to C1 plus C2 plus C3 whole into VO. We want VO. Therefore, VO is equals to this whole thing, C1 VA plus C2 VB plus C3 VC by C1 plus C2 plus C3. Which option? First option. That VA, VB, VC, they are given as V1, V2, V3. Sorry, this V1, V2, V3 only you take. So this one becomes is V1, VA is V1, VB is V2, VC is V3. So here it is V1, here V2, here the voltage given as V3. So symbols we are going to modify. Sorry, I forgot that I took it as ABC. This is 1, 2, 3. C1 V1, C2 V2, C3 V3 by C1 plus C2 plus C3 is the answer. Two capacitors connected in parallel, but two ends are connected to the earth. Earth is electrically neutral, but it can act as a positive terminal also, negative terminal also. Okay, and here in connected here, two terminals of the capacitors is indirectly, two terminals are connected to the earth only. This connected, two meanings are there. You can join these two connections also. If you take any capacitor, if you connect this like this, Okay, and it's just like this only, same, but you connected this to earth, does not matter. Whatever charges are giving, earth can take up any number of charges, still remains electrical neutral. Any conductor connected to the earth will have always zero potential. These 2 points you need to remember. Potential of the earth is zero, it is a reference potential. Potential at infinity of any charge is also zero. So in this case, whatever the charge you are putting it, that will go only. Whatever charge you are putting, that will go to the earth only. That means what is the capacitance? Here these 2 plates are not isolated now, they are connected here. They are connected by this earth. Means whatever charge are putting on the capacitor will go to the earth, and what is the charge remains on the plates is 0. What is the capacitance is infinity. Any charge you are putting going only. Means what is the capacity? Infinity. What you take is C is equals to Q by V. Answer. C equal to Q by. What is V? V is the potential difference between the 2 terminals of the capacitor. But what is the potential difference between the 2 terminals of capacitor here? VAB. But V here also earth, here also 0. 0, 0. What is the potential difference? 0. But potential difference between A comma B is V equal to VAB equal to V, I am taking it equal to 0. So this is 0. When Z is 0, C equal to Q by 0. What is anything by 0 is infinity. So capacitance is infinity. Next 155. This one is also important. Some of these problems will be repeated for the resistors also, similar shapes. 3 capacitors. This is 2C and this is 3C and this is C. All these ends are connected to the earth. Means common terminals. Earth is also called as a common terminals. And this point is A. What you are asked is, given arrangement 6 microfarad charge. So next question is 155. At point A into the circuit, you are given the 3 capacitors. One terminal is connected to A for all the 3, other terminal is connected to the grounding or common terminal we can take earthing. So one capacitor is C1, I will take it as a C3C, another is C, that I will take it as a C2, another is 2C, I take it as a C3. 3 capacitors, they come in parallel. You can rotate it this side, you can rotate this side, and common terminals you connect to the earth or just join them, you will get all the 3 capacitors in parallel. Parallel combination is resultant is C1 plus C2 plus C3. So C1, C2, C3 are parallel. What is common for the parallel potential capacitors is, devices is, potential difference V is constant. And C parallel resultant parallel combination is C1 plus C2 plus C3. The result becomes equal to 3C plus 2C plus C is 6C you will get. C is some value, whatever is the symbol given. So total charge is given at A. What question says is, charge Q equal to 6 microcoulomb is added at point A. So this charge is divided among the 3 capacitors, C1, C2, C3 charges. 3 capacitors charge is distributed. So total charge Q equal to C parallel to V. Q equal to CV relationship for the total relation. So V equal to Q by C prime, Cp. And total charge given in the question is 6 microcoulombs. Here it is. Careful with the C. This is a unit. That C is the capacitance symbol. And Q1 charge. Your question is, what is the charge on the C1? That's 3C. Q1 is equals to C equal to Q by V. So Q equal to CV. Q1 is equals to C1 into V. V is same here. What is C1 is 3C into V. What is V? We got is Q by Cp. Q is nothing but equal to given as 6 microcoulombs. Cp is nothing but equal to 6C. C symbol cancels, 3 to the 6. So 6 by 2 is 3 microcoulombs is the charge on it. Similarly, you can find the charge on the other capacitors also. What is the charge on Q2? Q2 is nothing but equal to C2 into V. You can calculate correspondingly. And what is charge on C3? Q3 is nothing but equal to C3 into V. You can calculate the corresponding charges. Total charge Q1 plus Q2 plus Q3 is supposed to be equal to Q. Next question is 156. We can easily work out that. In the 156, I will just give the hint only. In the question number 156, you are given 2 capacitor plates separated by some conductor. Shape is given as I or H, whatever you. This is not I, sorry, H symbol. This is a conductor. This is the conductor. Dielectric constant is K is equals to infinity. The separation of the plates is A and this separation is D. So you can take it as a partially filled dielectric, but K is equals to infinity formula. Okay, this K is metal, K equal to infinity for metals or conductors we can take. Partially filled dielectric formula what we have is thickness T is equals to D, thickness of the dielectric. K is infinity for metals, T is the D equal to thickness. Here given as D. Generally we take is the separation of the plates as D, but here this separation itself is not D, sorry, it is given as B. Thickness is given as B and separation is taken as A. So partially filled dielectric, if you take the partially filled dielectric, what is the formula is dielectric C equal to epsilon naught A by D minus T plus T by K is the capacitance formula you have to take. A is the area of the plates. Charges stressed, whatever the thickness you take, no, charges stressed only on the surface. So you can also take this effective capacity. This whole thing you take it as a one single block you have to take. Even the gap is there, does not matter here. You have to consider it as a single block of this much thickness and take the calculation. So we stop here. Next class I will try to complete this topic. After that we start current electricity.